Okay, so those test points, they've got their own footprints. You'll see those in a minute when we export to Ultiboard. You will notice, or maybe you won't, but I'll tell you, the R1 and C1 are coloured black, right? That means that they don't have a footprint. That means they're virtual. Now we want to change that, and the next stage that I'm going to show you isn't trivial, and you need to practice this several times to be able to do it. So the first one that I'm going to target is R1, and when I've got this right, it'll turn blue. In other words, it's got a footprint, but at the moment it hasn't got a footprint. So I click on it. Right click is usually the easiest way, otherwise you have to click twice. So I'm on R1 and I go down to the bottom and I go to Properties. On those properties, I then, as you can see, there's lots and lots of different things going on here. And this is normally where you change the value of the resistor and so on. But you'll notice down the bottom there is a little button that says Edit Package, yeah? Click on the Edit Package, and this window isn't particularly helpful, but it's to do with the number of I/O pins and so on. Go to the top and select from Database. Okay. Now you're in the database of components and footprints. So just take a few seconds to realise how we got there. So we clicked on the components, we went to Edit Package, we then opened up the next window, and finally we're in the Select Package window here. Now if you look at some of these, so I know that these are surface mount, these ones, just because of the way that they're drawn. But you'll see in this column here, there's a column that says SMT-TH. Now look at the difference, look. So if I click on it, I don't even know what that component is. But if I click on the SMT here, you can see that it's got little pads that would be used for on one side of a board. But if we look at this one, that's not a particularly good one, but you can see the blue on the inside. Let's see if we can find something a bit more suitable. Yeah, so there's an integrated circuit, and that's what we call through hole, that one. Well, we don't want an integrated circuit, and we don't want there's a surface mount integrated circuit. Here's a through hole integrated circuit. I want a resistor, don't I? So I want the footprint of a resistor. Now, if you look at that top right hand corner, you'll see the box that says filter. If I click on that filter, look what comes up, a blank window that's no good to man the beast. Well, it is useful, because what I can do inside here is all of those footprints, and there are thousands and thousands and thousands of them. All of those footprints, I can filter out things that are through hole and things that are resistor. Okay? So if I build two filters, a resistor and through hole, I should have a series of options for footprints that I want. But how do I do that? Well, first of all, let's filter resistors. So if I go into where it says filter and I click add row, told you this was quite protracted, didn't I? Where it says manufacturer, go down here and select package. Where it says operator, and it's got equal, select contains, and where it's got value here, select resistor. I don't know whether it's written in resistor, resistors, res, I don't know. But it seems sensible to me that in that database, if it's got anywhere in the description of it the word res, it's probably a resistor, right? So if I OK that now, you'll notice that all of my packages here, look down the package column, all contain the word res. Well, that's good, isn't it? That's a nice start, that. You'll notice that these are SMT and these are through hole. Now that's actually the one I want, but let's pretend I don't know that's the one I want, because that's a through hole one. What I'd like to do is get rid of all the SMTs, because I don't want the surface mount, I want the through hole technology. So what I can do is I can run another filter. So I click on filter, only this time I say add row, this time I say SMTTH equals, and in this particular case I tell it that I only want TH for through hole. I then OK that, and look what's happened here. So now in this database all I've got is through hole technology that contains, which is a prefix, but anywhere in its description the word res. And you'll see that they're all through hole resistors, all of them. Now across here, and this is, Mike, you've got to help me on this, this is thousandths of an inch they measure those things.
Half for PCC and millimetres for schematic. I don't know why, it's always been like that.
Yeah, but these numbers here are thousandths of an inch, so that resistor is 250 thou in thickness and 700 long, and actually 1300 by the time where the legs are bent in. We can discuss that with you as we go along. Now I'm going to choose that one, the top one. If you want to choose a different one, that's entirely up to you, but you can see that the dimensions are slightly different and they start to get a little bit longer or fatter or whatever you want. But I'm going to choose the top one. Okay. Now something else I could do at this stage, and it didn't work the other day, so I hope it's going to work this time. What I can do is I can just do a copy to, and I can put that into my user database. So I'm hoping that will do that. I'll check again in a minute, but don't worry for the time being. So that means that I don't have to do that search again if I want a resistor of the same manufacturing type. Okay, so I'm there, I've got the one I want, I select, I OK the rest of it because the windows that I'd opened, and look, my R1 has now turned blue. That means it has a footprint. Okay? And that means it has the footprint that I selected from that database. Okay? Again, we don't need to worry about that for the test points because they've already got their footprint and they're coloured green, indicating to me that I can't change their footprint. That's what that's telling me. So now I need to do it for C1. Go slightly faster this time now, so I need to find a footprint for C1. We know it's through hole technology, we know it's a capacitor. We click on it, properties, edit package, select from database, just have a look in the user database. Yeah, there's my resistor in, well, I'm not going to use that now, but you can see that I saved that footprint into my database. But into the master database, I'm going to turn on the filter, and the first thing I'm going to do is add a row. I'm going to say that I want the package to contain the word or the three letters CAP. C-A-P, not C-R-A-B. Okay, so CAP. And if we now say OK to that, everything that we see on here should have the word CAP in package, and it does, without any exceptions I can see. Trim CAP is a slightly different variant. Okay, and again, we don't want surface mount, well maybe we do, but not in this design, we don't. In this design we want through hole, because that's what I'm teaching you. So filter, add row, and this time we want to SMTTH, so the technology equals is fine, although it could be contains if you want, and then TH, click OK, and everything that you have down this list now is now a capacitor with through hole technology. Now those numbers are there to help you, so when you go along to the draw, you can actually just get a ruler and measure it, and you measure it in inches and then convert it to thousandths of an inch, and then it will give you some indication of what size the capacity you got out the drawer is compared to the real world. So if we go down here, well, let's try and find that big one somewhere here. I guess it's maybe a little bit too big. So there we are, something along those kind of lines is that one. okay?
So the numbers there are the height and the diameter. of
Yeah.
those two.
Yeah, in thousandths of an inch. And this little one I've got